Hey everybody. So after talking to some folks, it occurred to me that making a graph may not be the most intuitive thing in the world, and some of you may not have a whole lot of experience doing it. So I thought I would post this hopefully quick video, kind of leading you through the steps that you would need to go through in order to make a graph. And these graphs can be helpful for the factorial assignment. Because when you graph something and you use a line graph, you always know you have an interaction if the two lines cross. But there's a caveat to that. So say you've got a line like this and a line like this, all right? And that's on your graph. Well, yeah, technically on the graph, they don't cross. Actually, you know what? Let's do this. This would be, I believe, a little bit easier. Okay, so here's a graph. All right, well, let's say that you've got one line that does this, and you've got another line that does this. Now, on this graph, these lines don't actually cross right now. But what matters is if you were to project either of these lines out to infinity, would they ever eventually cross? Well, if we do that, the answer is yes. They would cross right here. That means we have an interaction here. So if the lines would cross at any time, you have an interaction. Now, I talked a little bit about bar graphs versus line graphs in the last video, and yes, although bar graphs are better for categorical when you have categorical IVs, you can draw the lines on a bar graph to see if there's an interaction as your book in the way that your book describes, and I'll show you how to do that at the end of the video. Okay, so let's first start with a couple of examples that I've come up with to try and show how to make a graph from an example. So the first thing we need to do is identify what's going to go here on the x-axis. All right. Also, by the way, just keep in mind, if at any point, I'm switching between things a little bit too fast, please remember, hit the pause button so you can kind of stop and take a look, and then, hit the play button and continue on. Now, so let's start with example 1. Now, I know this one is it's filled with a lot of jargon, a lot of terms that you're not familiar with, and that's okay, because really all you have to do is identify the variables. You don't need to be familiar with what the variables mean, what the variables are. All you need to do is identify what's having an effect on what, and then you can plot a graph and be able to see if there's an interaction or not. So let's start with this example here. Oh wait, you can't see it. Sorry, I apologize for that. There we go. Let's start with this example here. So promotion-focused people feel more right about their decisions when making those decisions by focusing on what they could gain than when making those decisions by focusing on what they do not want to lose. On the other hand, prevention-focused people feel more right about their decisions when making those decisions by focusing on what they do not want to lose than when making those decisions by focusing on what they could gain. Now, let's ignore this one just for a second, okay? Let's first focus right here. The first thing we want to do is identify our dependent variable, okay? So promotion-focused people feel more right about their decisions when making those decisions by focusing on what they could gain than when making those decisions by focusing on what they do not want to lose. So what is being done here? What is the end result? So we have promotion-focused people. That's not the end result, though. That's before something else, all right? Because they feel more something. So right off the bat, we can probably tell that the way they feel is probably our dependent variable. All right, because promotion-focused people, this implies something about their state, who they are. Okay, they're promotion-focused. So that's going to precede any behavior that they engage in. When making those decisions by focusing, so clearly they have focused on something before making a decision. So ultimately here, in this example, the dependent variable, remember, the dependent variable is what results. It's what's dependent on your independent variables. So here, in this example, our dependent variable would be feeling right. Okay, so we go to our graph, and in here, we type feelings of rightness. I know that sounds weird, but I'm not making it up. In the regulatory focused literature, they talk about feelings of rightness. Anyway, so we've got our DV. Now let's identify our IVs. Well, the first sentence by itself allows us to identify one of those IVs. So we have, they feel more right, so they have higher scores in the DV, when making decisions by focusing on what they can gain than when making those decisions by focusing on what they do not want to lose. So right there, we have one of our IVs, and it is the difference in focus. So we have people focusing on gain, and we have people focusing on avoiding loss. So we go back here to our graph, and what I typically do is I use this is a little hard if you're not familiar with the concepts, but if a variable seems harder to move around, okay, then I put it over here, okay? And for me, changing what you focus on, that's fairly easy to focus on, so I would put those down. I mean, that's fairly easy to change, so that I would put that down here. So you notice it says low end of the variable or one of the conditions, so I'm going to put focusing on avoiding loss here, and I'm going to put focusing on gain here. Okay. Now remember I said that I tend to use the things that are harder to change for these. Okay, so if we go back to our example, well, I guess we have to identify the other independent variable. But in order to do that, we get some indication from the first sentence, but we have to go into the second sentence for that. So here, this whole first sentence is about promotion-focused people. This whole first sentence is about promotion-focused people. This whole second sentence is about prevention-focused people. So that gives us our other IV, the other thing preceding the feelings of rightness, whether they're promotion or prevention focused. And because that seems like a more stable quality to me, I'm going to use these lines to signify promotion versus prevention. So we'll use the solid line for promotion focus, and we'll use the dashed line for prevention focus. Okay, now let's go back to the example. So we've got a line for promotion-focused people. Let's first just draw our line for the promotion-focused people. So they feel more right when they're about their decisions when making those decisions by focusing on gain than when focusing on what they on avoiding loss. So let's go back over here. So let's make a dot. So feelings of rightness for promotion-focused people are higher when focusing on gain than when focusing on loss. So we know that if we were to draw a dot, if we were to make a dot for how right promotion-focused people feel when they're focusing on gain, that dot would be higher. It'd be higher on the y-axis. I think I said x-axis earlier, sorry. It'd be higher on the y-axis than it would be on above when putting the dot above avoiding, focusing on avoiding loss. So let's just go ahead, put a circle here, let's format that so we can see it right quick. There we go. So when they focus on gain, they feel more right than when they focus on loss. Okay, so if we were to draw this line between these two, it would look roughly like that. Okay, I realize I'm a little off, but I think you get my meaning. Now, let's go back to the example. Now let's see about prevention-focused people. On the other hand, prevention-focused people feel more right about their decisions by focusing on what they do not want to lose, so avoiding loss, than when making those decisions by focusing on what they can gain. So we go back to our graph. Basically, that describes the exact opposite relationship. So, you know, we make a dot. So the prevention-focused people, when focusing on avoiding loss, they feel more right than when focusing on gain. So if we were to draw the line between those, now we can see that there's an X. The two cross over. That means that this description describes an interaction. All right. Now let's go through a second example, maybe with variables that you're more familiar with. So people eat more when they're hungry, regardless of whether they have a goal to lose weight or not. So again, let's start with our DV. So let's go back to our graph. We've got a fresh one here. Our DV, what is the end result? What is dependent on the other things in the sentence? People eat more when they are eating, right there. So dependent, they eat more when they're hungry, and that happens regardless of whether they want to lose weight or not. So we know that our dependent variable here is amount eaten. Okay, now got to figure out what's going here and here. Now again, I told you the conventions I use. You don't have to use those. Those are just conventions I use. The thing that changes, the thing that is more stable, I draw independent lines for, and the thing that's less stable, I draw on the x-axis. So if I were to go back to our example, people have a goal to lose weight or not is probably going to be a little bit more stable than whether or not you're hungry. Or at least in my head, it's that way. So if we go in here, then I would say hunger would be on the x-axis. So not hungry, hungry, okay? And here we would have goal to lose weight, no goal. Now, where did I get that? Well, let's go back to the example. People eat more when they are hungry, all right? Well, being hungry is leading to eating. So if we're running an experiment, you've got to have at least two levels. So we can assume that the opposite condition to being hungry is not being hungry. All right, so one of our IVs is how hungry they are. That's where I get not hungry versus hungry. The other IV I got because of the latter part of the statement, whether they have a goal to lose weight or not. All right, so right there we have our two conditions, goal to lose weight or not. So no goal, goal, no goal. All right. Now, remember that according to the description, people who are hungry eat more regardless of whether they have a goal to lose weight or not. Now, I understand from your personal experience, and my own personal experience certainly, that sure, when a person who has a goal to lose weight, even when they're hungry, they're going to eat, but they're probably going to eat less than those who have no goal. And that's very true. And so there is most definitely an interaction between these two variables. But for the sake of showing you what no interaction looks like, let's assume that, let's just take the statement at face value. Okay? So then then we can draw two dots for the people who have a goal to lose weight. All right, I'm gonna go back here and copy this dot so I don't have to redo everything. All right, so when they're hungry, they're going to eat more than when they're not hungry. And according to the statement, again, we're taking it face value, regardless of whether they have a goal to lose weight or not. So we go back in here. So if we draw the two lines, so that's people with a goal to lose weight, and this is people without a goal to lose weight. All right. Those lines are never going to cross at any point ever. All right, they're parallel. For that reason, there's no interaction. All right. Now, let's talk more realistically. Like, you're probably all assuming, well, yeah, everybody eats more when they're hungry, but the person with the goal to lose weight might not eat as much. So you might expect that this dot would be down here. If that's true, and let's say that even the people, let's say that people with the goal to lose weight always eat less than people without a goal. But it would still look like this. So the change is still different. So now, if we extend the lines out, they cross. And now we have an interaction. So if you have two lines that cross at some point, you have an interaction. If they don't cross, then there's no interaction. You may just have a main effect. Now, the last thing I want to show you is how you would convert a bar graph to a line graph. Sorry. So I'm just going to draw a couple bars in here. So let's make these bars represent basically what we just showed here. So a person who's not hungry, they're not going to eat much. And let's say sorry, I'm going to do some revision here right quick. Bear with me, please. I'm sorry. All right. So when not hungry, the person without a goal may eat slightly more. But when they're hungry, they're probably going to eat quite a bit more. Even the person with a goal to lose weight is probably going to eat more when hungry, but they're probably going to eat less than the person who doesn't have a goal. Now, this is a bar graph, and this is how you might represent the variable, the relationship we just talked about with the line graph with a bar graph. But you can convert this into a line graph very simply. And you do that by putting dots at the tops of the bars and connecting them. So if we wanted to see what the line for those without a goal would be, we would connect a line from here to here Let's make that a little bit more visible. And to see what the line for those who are not hungry or have no goal would be, we'd connect the top of this one to this one. And we get the exact same relationship we had before when we did the whole thing with lines. So now we have two lines and they cross. So we have interaction like you would expect. Now, you know, if we stuck to the description where we said there's people who ate more, or people who are hungry ate more regardless, then this bar would be here. Let's get those lines back. Then this bar would be here, and this bar would be here, and you'd have your parallel lines again. So you can convert a bar graph into a line graph really easily by doing just what I showed you. And the lines give you an easy way to see if there's an interaction. If the lines cross at any point, even off graph, if you were to extend them off the graph, if they cross at any point, then you have an interaction. If they don't, then you don't have an interaction, and you may or may not have a main effect. That is my attempt to describe to you how you can use graphs to identify whether or not you have an interaction. Now, as with all my videos, I beg you, please, if you have any questions, please contact me. I want to be able to, I am eager, I am passionate to help you learn these concepts. And if any part of these videos, you know, I can't get any feedback from you on the videos. If any part leaves you asking questions, please ask me those questions so that I can clear them up for you. All right, guys, that's it for this video. It's probably going to be it's probably turned into a fairly long one, and I apologize for that, but hopefully it's given you an extra tool in your toolkit for research methods. All right, guys, take it easy.